So let's start the physics component, not the boring math stuff. In physics, every single thing, every quantity is either a scalar or a vector. In fact, for the rest of this course and Physics 12, Jesse, anytime I introduce a new concept to you, number one, I'll tell you the abbrev. What letter are we going to use? Number two, I'll tell you the units. What do we measure it in? And then the third thing I'll tell you is whether it's a scalar or a vector. You will need to memorize those three things, the abbrev, the units, and whether it's a scalar or a vector. But I don't think you're going to need to make up flashcards or anything like that. You'll memorize it through sheer repetition because I'll just constantly flog it to death all the time. Is that okay, Mark? Okay. What's the difference between a scalar and a vector? Scalars have magnitude only. Magnitude is a fancy word for size. Vectors have both magnitude and direction. Let me give you some examples. An example of a scalar is mass. That object has a mass of 10 kilograms. It doesn't make sense to say that object has a mass of 10 kilograms due north. It just has a magnitude. There's no directional component with mass. Compare that with velocity. That car is traveling at 80 kilometers per hour due north. 80 kilometers per hour is the magnitude. Due north is the direction. Back to scalars. Time is a scalar. How much time has elapsed? 12 seconds west makes no sense. 12 seconds. Acceleration is a vector. If you're accelerating forwards, usually you're speeding up. If you're accelerating backwards, usually you're slowing down. Makes a difference. In fact, we're going to make a little chart here. The ones we're going to use the most, scalar, speed, vector, velocity. Brian, if you want an example of a speed, 65 kilometers per hour. If you want an example of a velocity, 65 kilometers per hour at 42 degrees west of north. That last little bit there, that's actually Physics 12. We're going to keep our vectors very simple. If something is moving forwards, we'll call it positive. If something is moving backwards, we'll call it negative. If something is moving up, we'll call it positive. If something is moving down, we'll call it. So we're going to deal with vectors this year, but pretty casually. If you talk to any of your friends that are in Physics 12 right now and mention to them vectors, you can ask them, hey, how do you add two vectors together? And we're doing some pretty much more heavy-duty vector mathematics in Physics 12. You will need to memorize that speed is a scalar and that velocity is a vector. Josh, if I was a good teacher, I'd have a dumb way for you to remember that speed is a scalar and that velocity is a vector. I can't think of anything that works. You'll have to come up with something on your own. Time is a scalar. There is no vector equivalent of time. Acceleration is a vector. I already mentioned those two. Although sometimes if we have objects, more than one object, and they're all accelerating at the same rate but in different directions, we'll just find the magnitude and we'll say you can figure out the direction by looking at the question. The trickier one, and I don't have a dumb way to remember which one is which. Distance is a scalar. Displacement is a vector. And that is going to make a difference this year. Unfortunately, they both start with DIS. If you come up with a dumb way to remember that the one on the left is a scalar and the one on the right is a vector, please tell me, and I'll use that for the rest of my teaching. I've memorized it through just Moses brute force, but I'd like a dumb, clever way. Tyler, we're also going to show a lot with notations. In the textbook, a vector is often shown with bold font. Don't write this down. So if they're showing force, for example, which is a vector, they'll bold font it. But you can see that's really tough to do in handwriting. And so what we do to show a vector, force is a vector, we put an arrow above it. Although we've gotten lazy and we actually only put one little pointy part of the arrow, and we don't put both. You can, but that's a vector. Write that down. Time, scalar, no vector sign above it because it's a scalar. Compare that with acceleration, vector sign above it. The slightly tricky one is that's velocity, V for velocity with the vector sign. And then once you've written that down, look up. Keep looking up. That's speed. It's the same letter as velocity, but no vector sign. We didn't come up with a different letter because velocity and speed are so related. They'll always have the same magnitude. They'll usually have the same magnitude, unless we're getting into really obscure, yucky stuff. But velocity will have a directional component. So scalars and vectors. Scalars, magnitude only. Vectors, magnitude and direction. Vectors have magnitude and direction. Scalars have no direction, much like your fugue. Okay. Distance versus displacement. Distance is how far an object has traveled. Symbol. Isaac Newton, who's really one of the fathers of physics, liked to use a lowercase s. And in Britain, they still do that. It comes from a Latin word for distance. Cross it out. We're not going to use it because that looks too much like a 5, and s is also the abbreviation for seconds, and s gets used elsewhere. Many textbooks will use an X or a Y. An X if it's horizontal because you're on the x-axis of a graph imaginarily. A Y if it's vertical because up and down is the y-axis of a graph. I'm not going to use those. I'm going to keep it simple. I'm going to use D for distance, which I have to be honest is technically bad teaching, but I figure those of you that get to first year university physics when you're doing it with calculus, you can easily make the switch to an X or a Y if necessary. Units, meters. Those are our preferred units for distance. What about displacement? Displacement is an object's change in position. Not the same as your distance, and I'll give you an example in just a few minutes. Symbol should be S with a vector. We're not going to use that. Should be X with a vector or Y with a vector to indicate left, right, or up, down. We're not going to use that. I'm going to use a letter D with a vector, and its units are also still meters. For those of you who are watching on YouTube, I'm sorry this won't make sense. You have to be in the class. But for those of you who are in the class, I'm going to do a little example with you. YouTube humans, I'm going to pause the video because it's going to annoy you. So again, sorry for those of you at YouTube, but hopefully that lets you wrap your brain around the difference between distance and displacement. I have a bad problem, and even 24 years into teaching, I will sometimes say distance when I mean displacement, and I'll try and catch myself, but it's just because they sound so much alike, I just sometimes miss it. We are going to because I did want to give you about 20 or 25 minutes to just work on stuff from the review. Who has not finished the study guide? A few of you. Who has not finished the practice test? So that's what you're working on, or you can work on your quiz corrections or any other outstanding assignments. If you're completely caught up, great. But we'll pick up with this on Thursday. Your quest is tomorrow. We'll pick up with this on Thursday, so don't lose this between now and Thursday.